Hello, 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 welcome, 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 welcome. Let's get into it. Actually, before I forget, I should write in Discord. Give me a second. I need to log in and everything. Oh, actually, it's kinda safe. Just need the 2FA. It's not what I wanted. God damn it. This. Alright, so that's that. And yeah, let's get into it. So today hopefully is the last day of the grid. Thank you for that, Captain Chica. Always appreciated. Alright, so let's evaluate where we were and then let's see what we need. Okay, so yeah, we were here. And one issue, well, one of the many issues is, first of all, the grid doesn't scale, right? It stays consistent everywhere, which is kind of not what we want, probably. I mean, we can change it, I think, based on here, right? Yeah. But not ideal, let's say it that way. Another thing is that the Y coordinate is a little bit badly shown, because it's currently only in like one dimension. It's currently projected by the YZ plane. That's it, YZ plane. So we project the ray into this direction. So basically, if I look at it from the Z plane, on the Z axis, it's basically invisible, because it's basically a flat line at that point. So I think we will address this first, this line here. Is it actually semi-transparent? No, it is not. Okay. So let's do that first. I think for that, what we'll do is, yeah, we will add a new function, I think, which is very similar to this compute grid line factor, but slightly different. Man, you knew what I mean. Compute normal axis line factor. We give it a hit position, a vec3 of ddx hit position, vec3 of ddy hit position. So it's very similar to this, just that we work on like the word position, because we kind of need anyways the word position here. Who are you? Who are you? Not Be happy that you have the opportunity. Distance is the length of the hit position in XZ. We probably will, you know what, we actually give it probably the 2D positions here, because we need to make it dynamic. Hello, Captain Chica. We just started, you didn't really miss anything. Hope you're doing good. Radial direction is basically our head position times. Do I have that already? Yeah, I do have it, right? Of the distance. What that does is it just divides it by 1, right? Or it's 1 divided by this. And if it's 0, it returns a 0. So basically we don't run into division by 0. And that is basically the radial direction we do, so that we can, basically we will render the y-axis as a billboard, more or less. Oh, I mean, I guess we can do ddx. How does emissive work? I mean, I don't think it has anything to do necessarily with a monitor. I mean, I don't know. In rendering terms, it doesn't have anything to do with a monitor. But in like monitors, I don't know. Not a hardware guy. Oops, minus. And then that with the radial direction. Well, I guess in this case it is kind of the distance, right? I guess we can. No, it can't. It's a cactus, what do you mean? I don't know what you're referring to, Chica. I just see a cactus. And that is the length of our vec2 of those two, basically. Yeah. And then the rest is more or less what we have already up there in the compute grid line factor, which is basically we have a draw width here, which is a max between our line width and the derivative. Then we have a float line AA, which is the derivative times the anti-aliasing factor. What is Onyx Plus? But no, I probably haven't. And that is our draw width. And that's very similar to what we already have everywhere, like minus line AA, sorry. And then draw width plus line AA. Oh no, sorry, it's plus minus, right? Yeah, it's up there. Plus minus. No, I don't. I have not seen. I have not seen. I'm not sure what you're referring to, so I'm curious. And then we basically return that line factor here, and we do the same thing. Well, I guess let's do it like that. Clamp between line width and the draw width and 0.0f, 1.0f. Perfect. Okay. Not sure about that, if we need a premium subscription. Not just kidding. What would you get even from that? Because I my stream times are so all over the place lately. But yeah. Okay, so here we do basically the new thing. So what we do is, first of all, well, no, so the orthogonal normer is not that anymore, but it's the dot. Sorry, not the dot. The normalized thing of here our ray. We need a vec3 ray word origin x, and then here 0, and that needs to change as well once we add the plane orientation to it. So that is our new normal, and then that is basically orthogonal hit position word and word, because we do it now in the, well, we already did it in word, it was just named wrong, and because the array origin was already in the word space. Okay, that is that, and then here we just check that our orthogonal hit position word is less than that. If it is, we get rid of that, and we just do a float or like normal axis factor compute normal axis line factor, and then that is basically our hit position. Let's actually rename them. And this one. And then let's rename this as well. Normal axis plane normal. It's a little bit stupid name, but it's basically what it is. Let's put it down. Then it's kind of clear. Has normal plane hit. And then this is change normal axis play. No, this. And this is our normal axis, hit position word, normal axis DDX, normal axis DDY. And I think the line width was your last one, right? Yeah, line width. Which is, I think, just our axis line width, yeah. Oops. Like that, and then that stays the same. We take that. We basically put that down here. Oh. And that's that. And I think, well, we need this one as well. And put that here. Oh, and then here as normal plane hit. I think that should be already it. Let's see if we made a mistake. Of course we did. And now this view is again broken. That's the only annoying thing with the Neobim, that I don't know how to resize this on the fly without the text being like scuffed afterwards. Oh yeah, I do what it is actually. Stupid me. So this one is XZ here. Because we said we would do that already on demand. Which of course I didn't do yet. But I mean, that's already nicely prepared, I would say. Then. Did I save? I'm not sure. Alright. Yeah, and now I think I can... Yeah, now it stays the same, right? Even looking at it from... directly from the Z-axis, it's there the same line. And we can even see that it like kind of rotates with us around the plane. So here it looks like diagonal now and it rotates. It's basically a billboard that like follows us so that we can always see the perpendicular or like the normal axis to the grid. And it basically goes infinite, up and down. And yeah, we split it already up and down, above and below the plane, so that the render order is correct, because here we wanted to, of course, to be behind the grid, and above we wanted with like in front of the grid. So here it's front, here it's behind. So that's that. But I think there is one issue that I already spotted when I started. Yeah, exactly. In the 0 point, we are basically in the green line, so we have like this flickering because we're basically in the axis line, so we need to prevent that because it's a little bit annoying. And I think what we can do for that is refactor this a little bit. Alright, let's take that here and do that if statement here. Has normal plane hit and normal axis hit position y is less than 0. And then we do this and we paste that here. And then we do here if the dot of our yeah, I think it's just the dot of the XZ, right? Of that 2D vector basically, and we do a dot because we wanted like the squared distance. So that is basically the same as the squared distance, and if that is less than the squared distance of the threshold that we want, let's say 0.1f, then we want to render the normal axis, right? If we are far enough away, which here is like squared, but that's like approximately like 10 centimeters, it's actually a little bit less because it's squared, like. So I'm not, yeah. Then we do that. And then let's do this, and we only calculate those 3 plane hits as well now. If we are close, or far enough away from the plane. I guess I did a mistake. It's ray origin word, right? No, it's this. Ah, wait. Okay, well, I need to move those up. Otherwise, that doesn't work. Yeah, no, it should work. Yeah, and now I can rotate here and it doesn't render it anymore, right? Because I'm inside it. And then as soon as I move out, it's rendered again. And if I get close enough, it will disappear again. So if we go here and then add some, yeah, no, it's gone, right? And it doesn't interfere with the view anymore. All right. Getting there. Let's look at the scaling next, I guess. Because that is fine. And the scaling will probably take a bit more time. Is everything still stable if I go super far away? That looks fine. Okay, so we didn't break anything, all good. Then if I go on the X coordinate here, where? Yeah, on the Z plane basically, or on the Z line here. All good. Beautiful. Alright. Scaling. So my idea was that... let's actually move that here. Intersect normal, intersect plane that is normal orthogonal to the grid plane. Yeah. And then here, alright, let's copy the comment from above. Here, no. Draw normal axis above grid plane. Okay. Good. So for the... I think we need to do the base calculation up here, where we do the scale factor already, kinda. And what I was thinking of is that first we get the camera height as an absolute value, because we don't really care if we are up or down. That again should be the correct one. So if we... well, we will deal with the coordinate stuff later, I guess. Now we have grid scale lever or scale factor. Let's do that, grid scale factor. Okay, I guess we could just do scale factor. And that is basically, I think I want to do it in like power of tens. So what we do is camera height divided by log of 10. What that basically does is every like at 10 meters we switch, at 100 meters we switch, at 1,000 meters we switch, 10,000, 100,000, and so forth. And then we get float minor cell size, I guess, which is power of 10 again, because that's our grid size. We might parameterize that later, but probably not, to be honest. And then we want an integer, a clean integer here, so we don't do intermediate scaling, right? And then we do it -1. I can, like, that is basically, because if we would just power of like the 10 of the 10 to the power of the scale factor, we would never go below we would never go below 0, or like actually in this case below 1, because 10 times 10 to the power of 0 is 1, because this cannot go below 0, right? It cannot be negative. So what we do is, if we are at level, if this returns level 0, we will return level -1, so then we go down to 10 centimeters here. And I don't think we need lower than that. We could even do an offset further than that, but I doubt we need that. But just in case, we clamp it as well to that. And then we do the same for the major size, which is just the minor cell size times I think the grid cell count, right? Would make sense, which is basically how many majors, well, how many minor cells are in one major cell, basically, is that. And I think we get rid of that, and then this is divided by, I think, the minor cell size, or the major? Well, it was the major, so let's keep the major cell size, probably. The rest stays here the same for now. We will probably need to scale this line size, but we'll do that in a second. Let's first try to figure out this part here. So this is grid scale, and grid scale basically was 1s here currently, so that would be equivalent to minor cell size, I'm pretty sure. And this would be as well minor cell size. And then this would be minor cell size as well. So everything that says grid scale is basically minor cell size, and everything that says grid cell count is the major cell size. That's how I would think about it for now. So that stays all the same. Word UV stays probably the same. So in here you can already see that we scaled the word UV here. So probably we would have to do the same in here. Then we scale the word UV so that the grid line size stays consistent. I don't think we use that. Let's get rid of that. This stays all the same. And here, this one needs to adjust. Or does it actually? Maybe not, because we already do this here. So maybe that stays. Let's see. Because it might be already a multiple of 10 anyways. Okay, yeah, that's scared because we were directly at 100, right? So now we are below. Well, let's open the camera here. We are below 100, so it's scared. Above 100, it's scared back like one level. And then at 10, it will scale again. So we are approaching 10. So we are still at 10, and then at 9 something, it switches over to the smaller grid. That is pretty much perfect. But yeah, you can see already that the line for the y-axis does not scale. But yeah, basically we have now more or less a grid that scales. But I want to do it one step further than that, because the jumps are quite huge, right? You can clearly see it popping. I think we can do a little bit better than that. But let's try to first adjust the y-axis. So the UV derivatives here, this one we probably need to scale. Or is it this one that we need to scale? Let me see. So here we scaled the UV and we scaled the DDX, DDY. So I guess we give it the scale factor here, maybe. Basically the minor cell size, I guess. I think it was here. Float, scale, and then would it's either that. So we definitely need to scale this one, right? This definitely needs to be something like that. But I'm wondering if I need to scale those as well. Probably, because I think the line will now be blurry. If it even works, great. No matching overloaded function, what? Ah, down there, right. Yeah. So is it blurry? No, but it doesn't scale very well. Or it doesn't scale at all, I would say. Yeah, so that was not it. That was not good enough. Actually, I think what we can do is calculate that only once, right? Don't need to do that 2 times. Basically, we can do a float here. Well, I guess we could do it like that. Oh, wait. Yeah, I mean, let's do that. Do it like that. Then we move this out. Yeah, that's about it. I think that makes it a little bit nicer, maybe. Because we as well do stat duplication. And then that one I'm not quite sure which one I have to scale, but let's try for now to just scale both of them like that. Maybe? No, that didn't do it. It's mostly because the distance. Oh, we need to scale this one. I think. Do we need to scale this like before the length or after the length? I'm not sure. Oh, that might actually have done it. Yeah, okay, that was it. Now it's scaled down, and now if we get closer, we're scaled down even more. Exactly. Perfect. Good. I think it's this, and this. Okay. All right. So that's that. Let's see that it still works. Perfect. And the question is probably we need to scale. Probably I need to scale the distance for the y coordinate, right? Because probably now I can end up in the line again, yeah. Because it's like thicker, so we might need to scale that as well. I mean, it's not as bad, but it kind of is, I think, because I have a, yeah, I don't want this, right? That you just have a straight green line in front of you. I'm wondering if we can just... I think the scale here is probably... Maybe I need to do that times... I mean, the scale factor is probably wrong, right? Maybe it's just if it's greater than the minor cell size. No, it's probably something with the draw bit. I think we would need to make this based on the draw bit, which I don't have now. But yeah, we can think about that later. the axis line draw with. I think that's better now. We could have even calculated that already, I think, right? Well, not really. But yeah. Okay, scaling. What I had in mind is that we tweak it a little bit, and for that, what I need is refactor a little bit the line drawing. In the sense of that we will add here. I mean, probably it's probably here. Well, actually, I think we can do it up here because then I can give it into the y-axis as well. Blend factor is a 1 minus of our smooth step, and here it's basically the percentage where we want to transition. I mean, that's maybe too far. Well, we can test it, right? But let's do 20% and 80% for now. And then this is basically the fraction of our scale factor. And that basically does, because the scale factor is always like 0.1, 0.2, how close we are to the next level, right? And then it swaps like back to the next level. And so basically this will tell us how close we are to a level jump, and it will give us a value between 0 and 1 of that. 1 being we move 1 level up, 0 being we move 1 level down, basically in the next move of the camera, more or less. Yeah, and then what we need to do, let's do the axis lines first, I think, because for that you will instantly see how it behaves. So basically we do a axis line width here, which we mix between our u constant axis line width and the u constant axis line width divided by the grid cell count, because that's basically the next level, right? Or in this case the previous level, because we scale from our current level here to the previous level, and we scale that based on the line blend factor, well, the blend factor we set. And I think that already does it for the axis lines. I think they should already scale now. So the moment we, yeah, you can see them getting thicker, I hope, and then thinner, and then they swap, right? And if I guess we see it better if we get like close here. So here they are thick, and then we get close to the next level, they already scale down, and then somewhere here we will probably jump. Yeah, and then they're there. So the lines, the red and blue line already scale. Guess we can do the same for the y-axis then. For that we give it again as well the scale blend factor, I guess. Well, I get actually we could probably just do that up here. And then here. That should already do it, right? Maybe not. Maybe we don't have a value, or do we? Did I? Did I paste it too far? Of course I did. Guess we can put that here. And then we have our sizes here. Yeah, I mean the the big grid doesn't do it. Like the rest of the grid doesn't do it yet, but you can see already that the lines are now getting thinner and thicker for the 3 axis. Now we should be getting up here, and they now scale up, and now they are the full size. All right. Let's do the rest of the grid and then let's see how that looks. So the rest of the grid is basically very similar in the sense that we just scale this major line width here in the same way. Basically we do a mix here between our next level, which is U constant's major line width, and the previous one again. Actually in this case, no, sorry, not that. Well, kinda, but it's basically the same. We do a minor cell width here. A minor line width. Because a major cell, when it scales down, basically becomes a minor line, right? And if a major cell scales up, it always scales up to a major line. That's the thinking here, and then here again, blend factor. We still need to divide that though by our grid cell count so that it's properly scaled like before. Before we did major line width divided by that, and now we do either major line or minor line divided by that because we need to still scale it appropriately to the UVs. And then the minor line is a little bit simpler because that one is just this. And then I think it's probably divide. So basically divide by the 10, which is our scale factor basically currently, I think. I think that's it. And then this is again our line blend factor. Or is it our line? Yeah, the blend factor. Actually, I think it's not that. Hold on, blend factor. I think this actually needs to be basically what this up here is. So I think it would be major line width divided by cell grid count. I think. Probably. Because it's basically the scaling up of a minor line to a major line, I think. So this is basically the fact of how we blend from minor to major. This is how we blend from major to minor, and the other axis lines are different, like they are special anyways. Let's see, the lines now should hopefully... Okay, yeah, I mean, You saw it here, right? The white line, it's like the same size, and then we move away and it gets thicker. And then if we get close, the fence fades out. And then if we get even closer, it fades in the thicker lines, yeah. So with that, we can now move away. It basically turns a little bit, and then slowly the thicker lines come in. Yeah, kinda good already. Maybe a little bit too slow, right? Because here you barely see a difference, and then it suddenly pops in. So there might be still a little bit better way to do it. I think one thing I would want to tweak is maybe the speed of it. And the speed is basically here, the smooth step. Oops. So I think 0.5 and 0.9 might be better. Well, not like that. So basically in the last 5% we do it. So it's basically a very quick transition. Did I? Yeah, of course I did. What? Ah, that does need to be an F here, probably. No? Okay, what else did I break? 114. Unexpected right parent. Oh. How did I manage that? Okay. So basically, we go in here, and then hopefully, so when does it happen? Why is the grid so, or whatever? Did I break it, or is it just so quick now that it barely is visible? I'm looking at this line. I mean, it's really almost not non-existent. Did I break it or what? Oh yeah, I did break it, okay. That was more. Jesus, how did I do that? The direction part was missing. How did I manage that? Alright. Now it should work again. Okay, that's better. So now it scales up and it's rather quick, right? It goes back and then the new grid comes in. But there's one thing I still don't like. This I don't like, that there is a grid. Like this minor grid, right? But then because we are probably, yeah, we are close to 1,000. So at 1,000 it suddenly pops out because we swap to the next one. And then we need to wait a little bit until the thicker lines come in because we fade them in over the next 5%. And then now it looks fine again, I would say. But before that, like, I don't like that here we just have like one grid size more or less, and then suddenly something pops in. So maybe we need to address that. Because I don't like that too much. But otherwise it's already pretty nice because it basically is, I mean, it even goes down here, right, to like, that's like one lever basically, and it's like, this is like a step of, I think 0.1, right? Yeah. And I don't think you will ever need that precision, but I mean, it's there. And then we go up here, and then it's like the major grid. Well, one is now a minor one. Are we that far away already? I guess. And then this is 10, yeah. Perfect. I think there is more. More. We are getting this done today. My research yesterday paid off. A little bit. On shader toy and everything. Ah, go away. Help. Go away, entity. Okay, so yeah, what I want to address now is this this big step here where one pops in to the other. What could we do about that? I guess with just two grid layers, there's not really a lot we can do, I think. Because we can always at most only draw 2. And here we basically have to draw the outer lines here and the inner lines already. So we basically have 2 active at the same time. I mean, it depends, right? Whatever you define as normal behavior. I mean, it's definitely fine, but I would think I can do it a little bit smoother. And I might have an idea for that. Let's try something. Oh, shit. Let's try... How do I do that? Probably up here. Is it up here? Maybe. Yeah. So basically what I would do is previous minor size, which is basically the same here, but we do minor size divided by U constants. Grid count. So basically this is the next, this is the major size, this is the current minor size, and this is the minor size below us. And I think we take that, fade previous lever minor lines. This is just for a smoother look when moving away. Okay. And I think we need to do custom UVs for that, for it to work. So basically kinda like that. Kinda like that. So this is previous minor UV. And I'm not sure, is that... I think it's inverted, right? It probably has to be inverted from the from the major line, so it's like this. Previous UV derivatives. And then we have... I don't know if we need an axis offset, but I guess we could do one. That one I'm not too sure if it's correct, but that is basically what we have here, so it's basically centered UV, I think. because it needs to offset based on the minor cells, I'd say. Something like that. Oh, actually, sorry. Like that. And we clamp here, then we do this. That's fine. And we don't need anything with the line width, I think. That's fine. I don't think we need to blend the line width in this case. And then this is previous minor grid line factor, and we do here previous minor UV, minor UV derivatives, minor line width, because this will always stay at minor line width, right? We will never scale those up. Previous axis offset, and probably the axis lines is fine. And we need to fade that in here as well. So that, oh well, that is fine. Minor color line. That is previous minor grid line factor times that times the blend factor. And we will do a custom one here because we definitely want to fade it out different. I'm not quite sure what a good value here is yet, but it's probably as well, well, it's for sure as well 1 minus. And then let's do a smooth step. 0 we want it to be gone, and like at 0, well, we want to see it from like 0 to a certain threshold. Let's do the half for now. That might be too much. And we do the fraction again of the scale factor, I think. At least it's the same that we use for the blend factor. Yeah, I guess we could store that so we don't do it 2 times. I mean, I guess we could calculate that up there as well. That might be too much. I don't know, 50% might be too much. Well, if you can't type, you can't type. Minor axis offset? Wait, what? Or did I make a mistake? $183 redefinition. Ah. Wait. Why do I have that 2 times? I think that's useless. I think that's a copy paste. Yeah, I think it's this one, right? I'm not sure. I think I copied it and then I copied the line and probably didn't remove it. Okay. So now we see that, and that's fine. Then we come here. And we can see it coming in already. I don't know if you see it on stream, maybe not. But yeah, now it's... Okay, the UVs are off, but There is something coming in. I think I probably did something wrong with the UVs. Yeah. But there's something I bricked with the UVs. Wonder what. Isn't it that? Oh, is that centered UVs here? No. Isn't that scale factor correct? Yeah. And then here we do minor line width. So that is, this one is centered UV times grid cell count. That's fine. Now we have previous minor UV derivatives, which is the UV derivatives scaled. Maybe that's not correct. The only downside now is we would render it 2 times. Okay, yeah, and now it comes in, right? And that's how I would want it, right? And we're still, like, now we are rendering basically 3 levels at once. And then we switch and now we are rendering 2 levels again. Just, I mean, yeah. And I think it's easier to spot here, right? So we go away and then we scale out, like we fade out the inner grid here. And now we fade in those outer lines, right? It's like a little bit better to see. So here we still have the thick white lines out here and the inner grid. Now we fade out the inner grid and we fade in those outer lines. And then we have 2 levels again. And we do that now for all transitions, right? So if we go, it's only 3 levels in like certain ranges, right? And I don't think it is, because we basically already do the same amount of work, because we still traced those points anyways, and then we said like, oh, there is no grid, because we do a full screen pass, right? We trace every pixel, so it already did that basically and said like, oh, there is no hit, so don't do anything. Well, there is no grid, so don't do anything. That's basically what it did, and now it just renders one more level there. Except for maybe that I added maybe a little bit more overdraw now. It shouldn't be a big thing. I doubt it's like more expensive because of that. And it at least, I think it looks better with that extra level. If it's really a performance problem, I can, well, I don't have a performance profile currently. But I guess we could evaluate that later. But so far I'm still at 144 milliseconds, so I don't really mind. For 104 milliseconds, 144 FPS. And I think it adds like super nice detail. I don't like that, but I think I will not deal with that. The exit lines, basically you can see better that they go into infinity. What is the circle when you look? Ah, you mean this up here? Well, this up down there. This bluish, yeah. That's, I think, I still have to debug it, but it's something related to the sky, because you have it up here, I think. Well, Actually, up here you don't have it. I think it's something with the sky shader that produces this. I'm not quite sure why. I never really looked at it yet. Oh, okay, we turned around. But yeah, it's something from the sky. I guess we could sooner or later look at that, but it's really not that important, I think, for now. Usually you have terrain anyways here, right? You will never see that. Okay, I think that's pretty cool. I think that's pretty nice. So one thing that I wanted to do is let's go to 8,000, right? That would be the next level jump, more or less. Well, at 10,000 we jump the next level. And I want to just test that. So at 10,000 we don't see any pop anymore, which is good, which is exactly what I wanted, because otherwise without this extra minor grid, this would instantly pop out at like 10,000. And now we scale up those lines and we fade out the outer grid. That should happen, well, sooner or later. Like 5% is like way more here. Ah yeah, now it starts fading slowly. I think, well, actually, sorry, we have 0.5, right? As the blend factor. Yeah, I think that's too much, to be honest. I think 0.3 is probably good enough. Maybe that's even too much, I don't know. So at, oh, that green line. So at 10,000 we go up, and now we scale in those outer lines here, probably. Yeah, they are scaling up a little bit. I don't know if it's easy to see. And now we scale out the grid and it's barely visible, and now it's gone. Yeah, that's pretty cool. I think that's really nice. And then if we get close to 10,000 again, it slowly fades in. And only here we render 3 grids at a time, right? Otherwise, down up here we don't. I mean, we still do the calculations, but it's really nothing expensive going on there. It's a couple of multiplications. And then we are here and we go below 10,000, and now everything is again basically only 2 grid levels. Nice. And I mean, I can compare it again, so let's do it one more time. So if we take that out, basically do 0.f here. Ah yeah, we need to fix this offset here. But we go now to 10,000, or like, yeah, let's go to 9,900. So basically right before the swap, and then you will see this just instantly disappear. And I think, yeah, and I think that's like, yeah, it's okay, but I think the version with the blend is nicer. So I think I will keep it, unless it's like really a performance issue, which I doubt it is. I think that's just majorly better. Let's see. So this one, why would you be not working? It's probably something stupid. So we have this one. It's maybe something more like that, right? It probably needs to be the same as the minor axis offset, just with a different UV. I think that's it. It's this, and then this is our centered UV, I think, right? Because the centered UV is what we draw the minor lines with, and then we offset those based on the centered UVs. Yeah, I think I took the wrong line. I copied the major line offset and not the minor line offset. So let's see if that looks better, right? It doesn't have the weird artifact that it had before. Yeah. Cool. I guess we could almost ship it. I think I have one more thing that I would want to add. But otherwise, I think the grid is done. And that one thing I want to add is... should be fairly easy. Well, actually there's two things, sorry. Well, one is a little bit more complicated, the other one is a little bit easier. Let's do the easier one first. How do I... well, it's more about how I would want to do it. Logic-wise, otherwise it's pretty straightforward. I think we will add a push constant here. Basically flags. And then the first flag is... well, it's basically one, right? Okay, and then if that is the case, then we basically do if is scale locked. Then we do our U constants grid scale. Otherwise we do that. And then we do none of the... well, I mean, this is basically all zero done. Guess the blend factor is 0 then, in this case. If it's 0 here, we go to major line width. If it's 0 here, we go to minor line width. And then here, this one we just don't do, I guess. So basically, if the scale is locked, we never render a third one. Guess we put that in here. Line colors we can retrieve up here. It's that line color we retrieve as well up there. So I guess if it's locked, we basically 2 as well, blend factor of 0.f. I think. Okay, let's try it. And then we go to our grid task. And we basically need to add a pool. I mean, that should be a little bit more sophisticated, right, than that, but it's basically that. Why is that not working? Like that? Alright, whatever. If you want to do it like that, we can do it like that. Then we need to GUI system probably. I did that right, yeah. That one is still a little bit painful that I have to do that, but whatever. And I would want to have those code generated. I think that's a to do as well. Guess I could for now have a registry myself, but yeah. Grid O shader. Is that not working or what? No operation exists that takes a left hand overhead off. What? Does that not work or what? I mean, that should, in my opinion, I mean, you can switch to Vulkan again or to DirectX 12 or whatever you're not at yet, or not what you're not currently doing, and then switch to that. Oh, okay, well, that one we cannot do up there. That one we need to do down here. What the hell is that? I don't even know how to pronounce it. Okay, so we basically have the scaling here, right? And now we have the minor grid here. Well, the second minor grid. And if we go in here and we say we lock it, then it basically, well, it changed it a little bit, right? Well, I guess it's better like that. And now we lock it to that cell size, and we don't scale at all. And if I untick it again, we scale. And then if I have it locked, I can lift up. Okay, ignore that. Oh, because I need to do it now in this, yeah, in like 1 steps, not in 10 like not in factors of 10, but in like factors of like 1 lever. Yeah. So basically you can decide which lever you want. I will probably add a nicer UI for that. And one that actually tells you the word unit instead of the lever here. But yeah, that's basically is that. So I could crank it up, right? And now this is like looking horrible, but in theory you can lock it and then you have your like your little thing that now is 100 word units, right? Always. And you would probably want that if you like want to position something very precisely and don't want to rely on the automatic scaling. Although maybe I do the line with scaling still. Although it might be a little bit weird to do that. But maybe it makes sense. I will think about that, I'm not sure. Because it's a bit weird that it doesn't... I think it could be nicer if the line with still scares. Good luck with that, that sounds like a lot of work. Unless you just write the repo for SDL and sell it as your own. I think nobody would... this feature will probably not be used a lot to lock the grid size, but it's still nice to have, I guess. So that was the one thing I wanted to add. Basically I can say, no, I always want to have level 1 here. Steam SDK has an SDL in there, yes. Mostly for controllers, I think. I think the only thing they use is the controller stuff, if I'm not mistaken. I think I need to make my blue and red line a little bit more prominent. They kinda blur in the distance with the sky and stuff like that. I don't know. Probably have to find a little bit better colors for that. Yeah, that's fine. Okay. Do I do the last feature now for the grid, or do I just ship it as is and we add the last feature of the grid somewhere in a later version? I think it shouldn't be actually. Is it a lot of work? Maybe it actually isn't so much work. I don't know. Let's try. I guess it's a flag maybe here. Is it a flag? Question never read. I mean, I guess it could be a flag, but then again, we waste here already a space here, so might as well axis or x-axis. Actually, no, hold on. We might do... Maybe we do a vec 3? What a direction. Let's reshuffle a little bit. So let's, well, okay, no, maybe not. That's 4. That's 3. Well, I guess we do have like 3 grid normer. And float grid distance. Or grid offset. Let's do grid offset, I guess. And then we do the rest. The grid offset we leave out for now, but so then this would be our, that would, I mean, how would I do that? Hold on. That normally is quite obvious how I do it, but how do I decide which? Which coordinates I take? Maybe we always do it in Y and we just flip the thing? That might work. I guess I could do inverse rotation here, right? I could inversely rotate those and this. And probably this then as well. Well, yeah. Something along those lines. We probably invert like those 4 into a local space. And that would rotate it. Probably. But then again, we can't really show those then. Well, at least they are not the world positions anymore in this case then. Or the world axis anymore. Okay, maybe we do that later. I need to think how I would want that. Because basically I think that would work, but then we would have a grid that can be freely rotated, which is can be nice, but can be as well not what we want. I don't know. Maybe I just want it to be rotatable in like 90 degrees. So it basically always stays axis aligned. I don't know. Not sure. I think we will do that later. I think that grid is already good enough now. And I will add... What did I just break? Well, I guess I did break something. Oh yeah, I broke the push constants. That's what I broke. Yeah, I think we will call it a day with that grid. That's good enough. And I will be back. Oh, it looks so nice. The fade in looks so good. I actually like it a lot. Yeah. We could maybe even speed up the fade a little bit. I don't know. It's a little bit of tweaking now, and I don't think we will do that now, but yeah. Yeah, I will clean it up tomorrow morning. Submit that to the dev stream. Dev branch stream. That was Perforce talk. To the branch, and then we will finally get back to the terrain, I think, for now, for real, because the grid is basically done. I don't think I need a whole lot more. I would want to eventually add, as I said, the rotating, but realistically that's like a stretch goal. But I might do that maybe when I need a break from the terrain again, or from whatever comes next afterwards. But probably a break from the terrain, because I'm not sure if we can do it in one go. But yeah, overall quite nice. I think it's really good already, the grid. I compared it last time. No, the physics. Yeah, it's mostly the physics. We never really did that. Mostly because I have to rewrite a little bit how the terrain allocates vertex buffers for it to work nicely with the terrain. With the physics, not with the terrain. Because currently the terrain just allocates like one big vertex buffer, and I don't think that's very feasible for physics collision. So we probably need to do smaller. It has already a chunk system, and that all works, but the final mesh is just one big vertex buffer, and I think I need to split that up per chunk and then sync back those to the CPU so that I can construct the physics mesh out of those. So that's the plan. Because the GPU is already kind of like chunk based. The problem is the vertex buffer. And for that I need a better or a smarter way to allocate memory and release memory on the GPU, and I kind of have more or less an idea how to do it, but yeah, it will be quite painful and probably a lot of me crying. No, I mean, they should hopefully align. That would be my ideal situation. There should not be a gap between them. There will be a gap in like physics terms, right? It's like two meshes next to each other, but I hope that this just works out with like the step size and stuff like that, that you don't fall in between there, right? And I hope it's smooth and there is not like a hiccup in the physics engine that you get stuck on like those, but I don't think you do, because in other games you have meshes next to each other and you can walk over them, right? So it should be pretty much the same. Indeed, fingers crossed. And we need to find out how expensive it is, because I have like a ton of mesh collision then. So I'm not sure if that's even feasible. I mean, then again, shouldn't be. Well, I mean, in other games you have height maps. I mean, it should be fine. Let's see. I don't know. We will find out the hard way. I really don't want to write my own physics engine. I really would want to avoid that. So let's hope George can do that. Can do what I needed to do. But there is already a couple of good examples that it should be doable and should be feasible with George, because there was like one voxel based engine. I saw a video recently from a guy that did like a SDF voxel engine, and he as well synced back the mesh around only around the player to the CPU, built the mesh out of, or like used that mesh that he synced back from the GPU and created a short physics mesh with it, and that was working in real time, so without performance problems. So the only difference to mine would be that I would want to have it for more or less the entire world, but yeah, that's about it. About it, and out further away from the player, the physics can be a little bit more inaccurate, or the mesh can be a little bit more inaccurate. Oh well. All right. I think I will do this. I will do a screenshot and then we'll maybe post that on like socials for the grid, because I think it looks really nice. And time to at least, well, I will reference at least as well the blog post, because I will not take all the credit, but at least I added a couple of things, right? So I can take some credit, but not all of it. And feel free, if you want to take it, WhatsApp for your engine, I don't mind. You can take it. Yeah, that's it for me for today. We will be back tomorrow. Let me think, because there was my fiance and I wanted to go out, do some groceries and stuff like that. So yeah, I mean, maybe it's 2:30, maybe it's a little bit later than 2:30. Something there, like, should be doable to be on time for the stream schedule, but if not, please, yeah, I will be here, but yeah, the time is a little bit. No, it's really just that anniversary is still half a year away or something like that. Yeah, pretty much half a year. All right. Thank you. If you are bored, Captain Chica, in your 3 weeks sick leave, you can always drop by in the stream. Yeah, have a nice rest of your evening. Hopefully see some of you tomorrow. For me, for like the stream of me suffering again with the terrain and GPU allocations. It will be fun. Thank you. Have a nice rest of your evening. Take care. Bye bye.